All right, so continuing our discussion of the chain rule, let's go back to the original, whoops, wasn't what I wanted to do. Let's go back to the original problem that I posed, which was the sine of x squared minus 4. Well, now that we know that we can just write this as a composite function, let's write that u is equal to x squared minus 4. The derivative of u with respect to x is equal to 2x, and y is equal to sine of u, which means the derivative of y with respect to u is cosine of u. So the derivative of y with respect to x is equal to cosine of u times 2x. But of course, I don't want this in terms of u, so I'm going to go back and I'm going to substitute in x squared minus 4 times 2x. And so notice that this is always the original, this is always going to be the original inside of the composite function. And we're going to talk about the idea of inner versus outer a little bit later, because there's a couple different ways to think about how to do these problems. And so then the process just becomes, which one is easier for you to think about. All right, so let's officially define the chain rule. So first of all, we need some caveats. The function f is differentiable at some other function. So it's important that it be differentiable or you can't take the derivative. Seems obvious, but we have to say it. That function g is differentiable at x. So again, we're having to sort of be very careful that the bit that we're looking at is this function differentiable, and is that other function differentiable? So then what we can say, and I'm about to use notation you may not have seen, so hold tight. F of g, that is the composite function, the derivative with respect to x is equal to the derivative of f with respect to u times the derivative of g with respect to x. So extending this a little bit further, we get the derivative of f with respect to g of x times the derivative of g with respect to x. Notation very quickly, f dot g means just a composition function, and another way to write that is f of g of x. And I apologize if my math notation that I'm speaking is not quite 100% on. I teach high school math. I tend to simplify things down significantly. So another way to look at this is, again, what we talked about on the previous page, that the derivative of y with respect to x, in other words, f with respect to x, is equal to the derivative of y with respect to u, that's f of u, times the derivative of u with respect to x, that's g of x. And so you can see the three things there. All right, let's do one more quick example. We'll call this example 3. And we've got some function of time is cosine of t squared plus 1. And we will let u equal t squared plus 1, which means the derivative of u with respect to time is 2t. And then we know that x of u is equal to cosine of u. X prime of u, which of course is the velocity of this particle, is equal to negative sine of u. And so now we can say that the derivative of x with respect to time is equal to, well, the derivative, I hate the fact that I switch back and forth in my notation. I'm going to just write this like this. Derivative of x with respect to u times the derivative of u with respect to time, which is negative sine u times 2t. And then, of course, rewriting it as a function of t instead of u and t, we get negative sine of t squared plus 1 times 2t. So velocity as a function of time can be written as that. All right. Hopefully that one wasn't too complicated, because I sort of did things a bit weird there, because I was talking about velocity and position and that in the middle of resolving the problem. So why don't you go ahead and, again, if you're in my class, do exercise 9, and we will be back with more. Thanks for watching.